Hi everyone. In today's lecture, we will discuss about difference between a++ and a is equal to a+1 expressions. So, as you know, both the expressions will increment the value of a by 1, but both the statements work differently behind the scene in Java. Means the final output will be same, but the way of working is different. Make this point clear. So a++ means post increment, right? In post increment case, value is first assigned or used in an expression and then increment by 1 takes place. Am I right? But at the end, both a++ and a is equal to a+1 is going to increment the value of a by 1. That is for sure, right? So before moving ahead with the story of a is equal to a+1, let me remind you one small concept. So the concept is when we apply arithmetic operators between two variables a and b, then the result data type is what? Max of type of a comma type of b comma int. Remember this formula. Fine. And also remember this diagram where we have seen that byte is what? A lower data type and double is what? A higher data type. So we are moving from lower data type to higher data type. That is called what? Widening. So you have to remember the formula and this diagram. Fine. Now it's time to discuss the story of a is equal to a+1. So let's understand the story by the help of example. So this is the example. Byte a is equal to 20, a is equal to a+1, system.out.println. I am trying to print the value of a. Is it clear? So here, what is this a+1? It's an expression. A+1 is an expression. So in this expression, we are adding 1 which is basically of int type. Why it is of int type? Because by default every integral literal is of int type. Now what will be the return type when we perform a+1? See, a is of which type? Byte type. Am I right? And this 1 is of which type? Int type. So the return type will be max of byte comma int. That is equal to what? Int. So it will return you int type of value. Which type of value? Int type of data or value. And you are trying to assign or store this int type of data into byte type of variable a. Because of this reason, you will get compile time error saying possible lossy conversion from int to byte. Now let's see the correct code with explicit typecasting. Fine. Now this is the new code, modified code. So see here, this part. This will return int type of value. I am correct? This will return int type of value. And I am performing an explicit typecasting to convert this int to byte. To convert this int to byte. Now it becomes what? Byte type of value. And I am assigning this byte type of value to byte type of variable a, which is 100% valid. Which is what? 100% valid. And you will not get any compile time error here, and it will compile and run fine and gives you an output what? 21. Initial value was what? 20 plus 1, that is what, 21. This story is pretty much clear to you. Let me show you this in the notepad. I have this class already, operators class I am using from the last 10 lectures. So I'm writing here itself. So int a is equal to, not int, it is byte a is equal to 20. 20. Fine. Now what I'm doing, a is equal to a plus 1. And I'm trying to print system dot out dot println a. This I am trying to perform. Go to the CMD or go to the location where this file is present. In my case, this file is present here. So open the CMD from here. Compile this file. Java C. What is the file name? Operators.java. See, you got this error, right? About this error only I was talking, right? Possible lossy conversion from int to byte. So how can I correct this code? By using explicit typecasting here. So how can I correct this? I have to do explicit typecasting. So byte here and this in one bracket. Save this and go back to the command prompt and compile once again. So after compilation, no error, right? Now Java, what is the class name? Operators. Hit enter. See, you got 21 as the output. That is what I have shown here. Where? Here, see, 21. This story is clear. Now let's move ahead. Now let's discuss the story of a++. Story of a++. So let's take one example. Byte a is equal to 20. A++ system.out.println. I am trying to print the value of a here. And you know what will happen? You want to check this? See, this program or code will work 100%. 100% fine, right? And the reason is here internal typecasting will be performed by compiler. That is the reason you are not going to see any compile time error. Let me show you. Let me show you this code. Here I just want to do what? A++. Save this. Go to the CMD. Compile. Compiled fine. Run this. Run fine. See, 21. 21 is the what? Output. Now go back. And the reason is what happens behind the scene, you know, this a++. What is this a++? This a++ becomes what? A is equal to type of a, then a plus 1. So in this case, you will not get compile time error and it will run fine and gives you 21 as the output. This thing is pretty much clear. Who is performing this thing for you? Compiler is performing. In the last case, you have to perform this. Fine. Now let's discuss some conclusive points. So the first point is, in the case of increment and decrement operator, internal typecasting will take place. Remember this point. And the second point is, I is equal to I plus 1 is much faster than I plus plus. So it is recommended to use this I is equal to I plus 1 instead of I plus plus. You know, there is a reason behind this, why I am saying it is much faster. So the reason is, you know, both the expressions uses different JVM instruction in bytecode. For example, I plus 1 uses I add instruction and I plus plus uses INC instructions. Means this, see, I plus plus uses which instruction? INC instruction. You know, that is the reason it is bit slower. And I is equal to I plus 1. Basically, I plus 1. This will use which instruction? I add instruction. Fine, that is the reason it is much faster. So I hope this much is clear to you. So this is all about the difference between A plus and A plus 1. So thanks for watching this video. Please subscribe our YouTube channel to get the further updates.